The National Electrical Code (NEC) requires a minimum of 4.2/0 copper wires for a 200 amp service. 3.2/0 copper wires are insufficient to carry 200 amps safely and reliably. A 200 amp service requires a conductor size of 4/0 AWG. 3.2/0 copper wires do not provide the same current carrying capacity as a single 4/0 AWG conductor. When multiple conductors are used in parallel, their current carrying capacity is reduced due to increased resistance and skin effect. In this case, 3.2/0 copper wires would provide a current carrying capacity of approximately 160 amps, which is below the required 200 amps. Using individual wires instead of a single cable makes it more difficult to ensure proper terminations and connections. Multiple wires in a conduit can increase the risk of overcurrent, overheating, and fire. The NEC specifically prohibits using multiple individual wires for a service entrance and requires using a single cable or raceway. It is recommended to use a single 4/0 AWG aluminum service entrance cable for 200 amp service. While it may be more challenging to handle, it is the safe and code-compliant solution. The National Electrical Code sets the standards for electrical installations to ensure safety. Selecting the proper conductor size is crucial for a 200 amp service to prevent overloading and potential hazards. The NEC mandates specific requirements for service entrance conductors, including the number of conductors and their minimum size based on the service's ampacity. For a 200 amp service, using 3.2/0 copper wires is not permissible because it does not meet the code requirements for current carrying capacity. The code requires either a single cable or a raceway containing conductors of the appropriate size. When multiple conductors are run in parallel, their ampacity must be derated due to factors such as heat buildup and proximity. In the case of 3.2/0 copper wires, the combined ampacity would be less than 200 amps, violating the NEC. Using individual wires instead of a single cable or raceway can also create challenges for proper termination and connection. Terminating multiple conductors can be more complex and may lead to loose connections or improper insulation, increasing the risk of electrical faults. The NEC emphasizes using a single cable or raceway to simplify terminations and ensure a secure and reliable connection. Additionally, using multiple wires in a conduit can increase the risk of overcurrent, overheating, and fire. When conductors are bundled together in a conduit, they generate heat that can cause the insulation to degrade over time. This can lead to short circuits, ground faults, and potentially fires. The NEC restricts the number of conductors allowed in a conduit to prevent overheating and ensure safe operation. Using a single cable or raceway minimizes the risk of these hazards. While aluminum service entrance cable may be more challenging to handle due to its stiffness, it is a safe and code-compliant solution for a 200 amp service. Aluminum conductors are typically larger than copper conductors for the same ampacity, but they are lighter and more cost-effective. Aluminum service entrance cable is designed for direct burial or installation in conduit and is suitable for outdoor use. When installing aluminum service entrance cable, it is essential to use the appropriate connectors and fittings to ensure a secure and reliable connection. Aluminum connectors must be specifically designed for use with aluminum conductors to prevent corrosion and maintain a good electrical contact. It is also crucial to follow the manufacturer's instructions for torquing the connectors to ensure proper compression. Proper grounding and bonding are also critical aspects of a 200 amp service installation. The grounding system provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The bonding system connects all metal parts of the electrical system to the grounding system, ensuring that they are at the same potential. The NEC specifies the requirements for grounding and bonding, including the size and type of grounding conductors, the location of ground rods, and the bonding of metal enclosures. It is crucial to follow these requirements to ensure a safe and effective grounding system. In summary, using 3.2/0 copper wires for a 200 amp service is not compliant with the National Electrical Code. The NEC requires a minimum of 4.2/0 copper wires or a single 4/0 AWG aluminum service entrance cable. Using individual wires can increase the risk of overcurrent, overheating, and fire. It is essential to follow the NEC requirements and use the appropriate conductors and fittings to ensure safe and reliable electrical installation. Remember to consult with a qualified electrician for any electrical work to ensure compliance with local codes and regulations. This information is for general guidance only and should not be considered a substitute for professional advice. Always consult with a licensed electrician for specific electrical installations and to ensure compliance with all applicable codes and regulations. Ignoring electrical codes and best practices can lead to dangerous situations, including electrical shock, fire hazards, and equipment damage. Prioritize safety and consult with a qualified professional when working with electricity. Understanding the National Electrical Code is essential for safe and compliant electrical installations. The NEC provides detailed guidelines for conductor sizing, overcurrent protection, grounding, and bonding. It is updated every 3 years to reflect new technologies and best practices. Electrical inspectors use the NEC to verify that electrical installations meet the minimum safety standards. Failure to comply with the NEC can result in fines, project delays, and potential liability. The NEC covers a wide range of electrical topics, including wiring methods, equipment installation, and special occupancies. It provides specific requirements for residential, commercial, and industrial installations. The NEC also addresses safety concerns related to hazardous locations, such as areas with flammable liquids or gases. Familiarity with the NEC is crucial for anyone involved in electrical work, including electricians, contractors, and engineers. Continuing education courses and training programs are available to help professionals stay up to date with the latest changes to the NEC. In addition to the NEC, local codes and regulations may also apply to electrical installations. Local jurisdictions may have additional requirements or amendments to the NEC to address specific local conditions or concerns. It is important to check with the local building department or electrical inspector to determine the specific codes and regulations that apply to a particular project. Compliance with both the NEC and local codes is essential for a safe and legal electrical installation. The proper selection of conductors is critical for the safe and efficient operation of electrical systems. Conductors must be sized to carry the intended current without overheating or causing excessive voltage drop. The NEC provides tables and formulas for determining the appropriate conductor size based on the ampacity of the circuit and the ambient temperature. Conductors are available in various materials, including copper and aluminum. Copper conductors have a higher conductivity than aluminum conductors, but they are also more expensive. Aluminum conductors are typically used for larger service entrance conductors and feeders to reduce cost. When using aluminum conductors, it is essential to use connectors and fittings that are specifically designed for aluminum to prevent corrosion and ensure a reliable connection. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds the rated ampacity of the circuit. Circuit breakers are resettable devices that can be manually turned back on after a fault has been cleared. Fuses are single-use devices that must be replaced after they have blown. The NEC requires that overcurrent protection devices be sized to protect the conductors in the circuit. The ampacity of the overcurrent protection device must not exceed the ampacity of the smallest conductor in the circuit. Grounding and bonding are critical for electrical safety. The grounding system provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The bonding system connects all metal parts of the electrical system to the grounding system, ensuring that they are at the same potential. The NEC specifies the requirements for grounding and bonding, including the size and type of grounding conductors, the location of ground rods, and the bonding of metal enclosures. Electrical installation should be performed by qualified and licensed electricians. Electricians have the training and experience necessary to safely install and maintain electrical systems. They are familiar with the NEC and local codes and regulations. Hiring a qualified electrician can help ensure that the electrical installation is safe, code compliant, and reliable. Regular electrical inspections are essential for identifying potential problems and ensuring the continued safety of electrical systems. Electrical inspectors are trained to identify code violations and other safety hazards. They can recommend corrective actions to address any deficiencies. Regular electrical inspections can help prevent electrical fires, shocks, and other hazards. It is important to follow the recommendations of the electrical inspector and address any identified issues promptly. Electrical safety is everyone's responsibility. Homeowners should be aware of basic electrical safety precautions, such as avoiding overloading circuits, keeping electrical cords in good condition, and not using water near electrical outlets. Businesses should have a comprehensive electrical safety program in place, including regular inspections, employee training, and emergency procedures. By following these guidelines, we can all help prevent electrical accidents and injuries. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution when working with electricity and consult with a qualified professional if you have any questions or concerns. The National Electrical Code is a comprehensive set of standards for electrical installations. It is important to stay up to date with the latest changes to the NEC to ensure compliance and safety. Electrical safety is a shared responsibility. By following the NEC local codes and best practices, we can all help prevent electrical accidents and injuries.